Hi everyone! Today we're going to talk about subtracting polynomials. And subtracting polynomials is something that students seem to really struggle with. I'm not sure if it's the understanding or the execution that they have trouble with, but I'm just letting you know that it is something that can be challenging, so pay close attention and make sure that if you're not understanding something, you do ask questions. First thing I have to do, of course, is fix a typo on my page. This should say subtracting integers, not adding integers. Okay. And we're going to start with working with integers just to show you patterns of things, okay? So the first example is 5 minus 2. So over here, I've got 5 little red squares. These each represent 1. And I have 5 of them. I'm going to take 2 of them away. I have 3, okay? Groundbreaking, I know. With the algebra tiles, the way we would show that is I have the 5 drawn here, and I take 2 of them away. So I might draw an arrow to say they've gone away. I might cross them off like this, whatever the mood is for me. And the answer is 3. You can clearly see we have 3 of them left. Okay. There's another way that we can do this, which is to add the opposite. And we've done this with integers, right? We've talked about adding the opposite. So instead of taking 2 away, I'm going to add negative 2. So 5 minus 2 becomes 5 plus negative 2. So I'm going to add my negative 2. And then I've got some zero pairs. So a plus 1 and a minus 1 equals 0. And another plus 1 and a minus 1 equals 0. So I can just take those away, and I'm again left with 3. Okay, so that equals 3. And that's just a different way of doing it. The way I would draw that out is I would add the 2 negative 1s there, and then I would cross out my 0 pairs. All right? So that works really well when you've got more things than you want to take away. What happens if you start off with 2 and you want to take away 4? Well, how can you take away something you don't have? What I can do is I can add some 0 pairs, right? If I add that, I haven't changed what I have there. I still just have 2 because this equals 0, but I've changed its shape. It looks different. And then I can add another 0 pair. And again, it looks different, but it's still just 2, right? But now I can take away 4 because now I've got 4 red ones that I can take away. So I can take that away, and my answer is negative 2. So 2 minus 4 equals negative 2. And I would show that by drawing 2 0 pairs like that. Okay, and then I can take away the 4 positives. Okay, the other way I can do this is by adding the opposite. So 2 minus 4 becomes 2 plus negative 4. So I'm going to add 1, 2, 3, 4 negative 1s, and I'm going to come and do that over here. So I've got 2, start off with my 2, and I'm going to add negative 4. And now I've got some 0 pairs that can go poof and disappear right there, and I'm left with 2. Okay, so 2 plus negative 4 equals negative 2. And I can see that drawing here. If I take these away, I'm left with negative 2. Okay, I'm going to pause, and I'm going to let you're going to pause actually, and you're going to do the 6 minus 8 and draw that out. Okay. Okay, so hopefully you got the answer of -2 there. Okay, now we're going to try this subtracting polynomials using algebra tiles. Note that I've made a correction on the screen there. There was a typo. It said adding polynomials. It should say subtracting polynomials. And this is this is a copy of the algebra tiles page that I gave you. If you were printing it at home, actually either way, what you would do is color the front page so that it's a color, and then when you flip it over, the back side will be white. Now mine is actually blue because my original ones, it's really hard to tell the difference between the colored side and the back side in this light, so I wanted it to be more obvious for you, so I made some blue ones. But the idea then is that the one side is colored, that's the positive, and then the same shape flipped over is negative, so you've got lots of tiles to manipulate, to play around with this at home. Okay, so our first question is 4x plus 5. So I have 1, 2, 3, 4 x's plus 5. So I have 1, 2, 3, 4, 5. Okay, and I want to take away, so I'm taking away what's in the brackets, right? So I'm taking away a 2x and I'm taking away 3. So I'm taking away 2x and I'm taking away 3. Okay, so what I'm left with is 2x plus 2. And if I do this on my drawing over here, I'm taking away 2x. Whoops. Let's try that again. Taking away 2x, and I'm taking away 3 ones. And so what I'm left with is 2x plus 2. All right. Now the other way I can do this is by adding the opposite. So when I look at this with my algebra tiles, I have 4x plus 5, and I want to take away 2x plus 3. So instead, I'm going to add negative 2x minus 3, or I'm going to add negative 2x and negative 3, because those are the same thing, right? So I'm going to add negative 2x and negative 3. 1, 2, 3. Okay, and now I've got some zero pairs that I can get rid of. There's 1 0 pair, there's 2 0 pairs, 1, 2, 3 0 pairs worth of ones. And I'm left with 2x plus 2 again. So this equals 2x plus 2. All right, let's look at another example. I have 5x minus 4, and I want to take away x minus 2. So, okay, well, I can do that. I can take away an x, and I can take away minus 2. I can take away an x, and I can take away minus 2, and I'm left with 4x minus 2, which is what I have on my tiles. Or I can add the opposite. I can change this to plus negative x plus 2. Okay, so if I go back to my 5x minus 4, I can add a negative x and 2 pluses, 2 plus 1s. All right, oops, plus 1s. okay? And then again, I'm looking for my zero pairs. So there's a zero pair, and there's a zero pair, and there's a zero pair. And I'm left with 4x minus 2 again. Always makes me happy when I get the same answer going two different routes, because that's how math is supposed to work. Oh, this one's complicated. Okay, let's try this. So this time I have, well, let's just get rid of all of that for now. Whoops. Easier said than done. All right, I have negative 3x squared. So there's 1, 2, 3 x squareds minus 4. So 4 little white ones, 1, 2, 3, 4. And I want to take away 2x squareds plus 3. Well, I don't have 2x squareds plus 3. So I can add zero pairs. I can add an x squared and a negative x squared. And I can add another negative x squared and x squared. And I can add there's a 1 and there's a, well, I mean adding a 0, right? And there's a 0 and adding a 0. So again, like I keep saying, all I've done is change the shape. I still have negative 3x squared minus 4. I haven't changed what I have. I've just made it look different. But now I can take away my 2x squareds, and I can take away my 3 ones. Okay? And I'm left with negative 5x squared minus 7. And I guess I can draw that out. It won't kill me. Okay. So now, you know what? I don't feel like drawing it out. So let's not. You saw it on the tiles. That's better than drawing it out anyway. Okay, the other way we can do this is to add the opposite. So instead of subtracting 2x squared plus 3, I'm going to add negative 2x squared and minus 3. Okay, so I'm going to go back to what I started with. 3x squared minus 3x squared minus 4, and I'm going to add negative 2x squared and negative 3. And I don't have any zero pairs this time, so I don't need to take anything away. I just right away have this equals, actually I'll draw this one in because I don't have to draw so much. So I'm going to add negative 2x squared and minus 3. So that this equals negative 5x squared minus 7. Sorry, minus 7. Okay. One more example. I have 2x squareds plus 3 and I want to take away a whole bunch of stuff that I don't have. So I don't even want to do that. I'm just going to jump right to the adding the opposite. Okay, so I'm going to add minus 3x squared minus 2x plus 5. So I'm changing the sign of everything that's inside the brackets. Okay, so the 3x squared started off positive, it becomes negative. So I'm going to add 3 negative x squareds, and I'm going to add 2 negative x's, and I'm going to add 5 ones. 1, 2, 3, 4, 5. And then I need to check for zero pairs, so I'm going to take away, there's one zero pair, there's another zero pair, and I'm left with negative x squared minus 2x plus 1, 2, 3 plus 8. So I'm going to draw that in. So I'm going to add 1, 2, 3 negative x squareds minus 2x plus 5. 1, 2, 3, 4, 5. So what I'm left with, oh, I need to take away, there's a zero pair, and there's a zero pair. Those all go away. And I'm left with negative x squared minus 2x plus 8. Okay, so adding the opposite is, with algebra tiles, either one actually will work, but adding the opposite is the one that I want you to focus on, and you'll understand that the next section we do. But for now, I want you to pause the video, go and do this first assignment with the algebra tiles, and then come back and do the next part of the video. Okay, but do the algebra tiles work first. All right? See you in a bit. Okay, now we're going to do subtracting polynomials symbolically. And all you do is you add one little step in, and then you add them. You're just going to add the opposite. So instead of having 2x minus 3 minus negative x plus 2, we're going to have 2x minus 3 plus x minus 2. So all I've done is I've changed the minus to a plus here, and then I've changed the signs of everything that's being subtracted, changed it to the opposite sign. All right, now I'm going to drop the brackets. This becomes 2x minus 3 plus x minus 2. And then I can collect my like terms. So I'm going to have 2x plus x minus 3 minus 2, which is 3x minus 5. All right, there are a few things that I need you to note here. Okay. This first line, this one here, and where all I've done is I'm leaving it in brackets. And this line here where I've collected terms, these are technically optional. Okay, that one and that one are optional once you are good at this. Okay, and when the question is small. When the questions get really big and hairy, it's not worth skipping those steps. But the other thing I need you to know is that this line right here, where you have rewritten your subtraction as an addition, is non-optional. Big arrow. Non-optional. Okay? No matter how good you get, you're still going to need to write that line out if you want to consistently get the answer right. Okay? My kid was studying engineering at university. My kid is very, very good at math. My kid writes this line out every time. When you're in a class of pre-Cal 12 students, the students who are doing well write that line out because they know it's too easy to make a mistake when you try and juggle it in your brain. So please, please, please write that line out every time, no matter what. All right? Okay, pause the video, go ahead and do the next one, see if you can do it on your own, and then come back and check your answer. Okay, notice this line here is non-optional. Oops, option. Oh, it's getting too late at night. Okay, you have to write that line out if you want to get these questions right. All right? Okay, go and do the next part of the assignment in the textbook. Refer to the front page of the package to see what the assignment actually is, and go and do that practice. And then there's one more example that I want to show you, so come back and watch that after you've done some practice. Okay? Okay, last example. This is mixed operations. There's nothing new. Just go slowly and carefully and show all your work. Okay, pay attention to what you're adding and what you're subtracting. So I'm going to show all the steps. I'm not going to skip anything. Notice that this is a minus sign here. Okay, you're only subtracting this part. Okay, you're adding this chunk at the end. So this becomes, I'm actually going to skip the brackets. So that's 3a squared minus 2a plus 5. That's just the way it was written. And then I'm adding negative a squared, so I'm just going to write that as minus a squared minus 2a plus 4. And then nothing here is changing because I'm just adding it. So again, I could put plus negative 4a squared, but I'm just going to put minus 4a squared minus 3a minus 1. So the important thing is that the coefficient of these ones has not changed. It's still negative. These ones have all changed their sign, and these ones, because these are added to 0, right? You start off with 0, they stay the same. Okay, now because this is a fairly long question, I am going to rewrite it and group my like terms. So I get 3a squared minus a squared minus 4a squared and minus 2a minus 2a minus 3a plus 5 plus 4 minus 1. Okay, and then I go and I just check that I have actually underlined all of the terms up here in case I missed one along the way. All right, 3a squared minus a squared minus 4 squared is minus 2a squared. Minus 2a minus 2a minus 3a is minus 7a. 5 plus 4 is 9, minus 1 is plus 8. Okay, that's the end of this section. So go and make sure you do all the practice and check your answers really carefully, okay? Because that really is going to matter, that you get that you check that your answers are correct, okay? Those pluses and minuses really matter here. All right, thanks for watching. Bye.